Welcome to LabMinutes.com and our lab video series on IPv6 on a Cisco router. You can find a complete list of IPv6 video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In this video, we're going to walk you through configuration of RIPng and IPv6. We're going to start off with some RIPng basic configuration, and then we'll look under the routing process and adjust things like administrative distance and maximum number of equal cost paths. We're going to look at how to use the matrix offset to manipulate the routing metrics and how to advertise the default route into the network. We're going to finish this off by looking at the route filter, redistribution, and some route summarization. Now for our lab setup, we have three routers in our topology. Router R1, R2, and R3 each has 4 loopback addresses configured, loopback 0 through loopback 3. R1 and R3 are connected over VLAN 123, while R2 and R1 are connected through a point-to-point serial link. And I just want to remind you that this lab diagram is available for download on the video page on our website. So let's start off with our task number 1, here with basic configuration. We first going to enable RIPng between R1, R2, and R3 as shown in the diagram, and then advertise their loopback interfaces. And then we're going to increase the administrative distance from 120 to 130, and then increase the number of equal cost path, or maximum equal cost path, to 32. Okay, so now let's log into router R1, and then start our configuration by enabling RIP on the interfaces. You can see here R1 the diagram, you have to enable on the loopback 0 and then fast 00 and serial 000. Okay, so let's get under the loopback 0, and the command to enable RIP is IPv6 RIP to question mark. Now we have to give it a name for the RIP process. I'm going to call it LM, and then to enable we'll type enable. Then we get under fast 00, do the same thing, and also 0000, and enable that as well. Now let's go over to R2. Let me kind of rearrange this tab a little bit to make them in the same order as the router shown in the diagram here. So router 3, 1, and 2, so 3, 1, and 2. On router 2, let's first enable the debug IPv6 RIP so we can monitor the RIP messages, and then we get under the loopback interface, IPv6 RIP, LM, enable. See, we're getting some messages already, and then we go under the serial 000, and then enable RIP there as well. Just gonna let that messages run real quick, and then we do show IPv6 route RIP, so hopefully we are learning R1 loopback 0 right here, and the VLAN 123 IP subnet as well. Okay, so let's scroll up and look at some of the debug messages real quick. So you can see here, as soon as we enable the RIP on the interface, for both loopback 0 and the serial link, it starts sending out the multicast request to look for neighbors to the multicast IP of RS0039. And since we have a neighbor of a serial interface, we receive the RIP response over here, and this is a link local address that belongs to R1. You can see if you do show IPv6 interface, you can see it ends with 5280, and then talking back to R2 with the link local address that ends with 3398, and then it goes through the route updates, and down here we see the list of prefixes that's being exchanged between R1 and R2. Okay, so it behaves just like any regular RIP or RIPv2 for that matter. And obviously we just check our routing table and we can see the routes. And let's hop onto R1 and do the same thing with show IPv6 router RIP, and here is the loopback of R2 that R2 advertised. Okay, and on R2, if you're trying to ping R1 loopback, which is 2001 1, sourcing from its own loopback 0, and you can see that it's now pingable. Okay, so now let's hop on to R3 and enable RIP. So under the loopback 0 IPv6, RIP LM enable, and then we'll get under the fast 00, which is facing R1, and enable RIP there as well. Give it a couple seconds, and then we'll just show IPv6 route RIP. And here you can see R3 learns the loopback address from both R1 and R2, and also the serial link between R1 and R2. And if you now ping from R3 all the way to R2, sourcing from loopback 0, and you can see we have a reachability. Okay, so now let's do some show command on R1 now that we have enabled RIP between the 3 routers to show IPv6 RIP. Let's see what some of the options that we have. Let's look at the next hop. And here you see under the list of next hop has the linked local address of both R2 and R3. And it has the interface that connects to that particular next hop show up there as well. So 0000 and then fast 00. Okay, if you show IPv6 route RIP, just to make a quick note that the next hop IP address for both routes are actually the linked local address of the corresponding next hop and not the actual global address. Okay, so now let's get under on R1. As specified under our task here is to change the AD and then change the maximum equal cost path on R1. So get under router process on R1, which is IPv6 router RIP, and make sure you specify the name of the process, which is LM. Do question mark. We have a command distance here to adjust the AD. So we're going to change it from 120, which is the default, to 130. And then on the maximum path, you can see you can go all the way up to 32. So we're going to choose 32. Okay, and now if we do show IPv6 route RIP, you see here the AD has changed to 130, while before it was 120. Okay, so that's pretty much all we need to do for task number 1. Now for our next task number 2, with the route metrics and default advertisement, we're going to configure R1 to increase the metrics of our routes received from R3 by 3, and then we're going to configure R2 to advertise default route. So in order to increase the metrics of the route, we're going to use offset or metrics offset command. So again, referring back to the diagram, so any routes that's being learned by R1 from R3, we're going to increase it by 3. So we're going to configure the fast 00 interface right here for R1 as the routes being received. So before we do that, let's do a quick show IPv6 route RIP on R2 so we can have that to compare before and after. Now on R1, we'll get under interface fast 00, and then under IPv6 RIP LM, we do question mark. You can see there's an option for metrics offset here, and then the question mark, we have a choice to go up the way to 16, but since our task say we need to increase it by 3, so we'll choose 3. And then we're going to give it a couple seconds again, and on R2, let's do up arrow. And let's also do debug IPv6 RIP, enter. Looks like the update is not quite coming in yet, so let's do show IPv6 route RIP one more time, and there you go. You can see the loopback address of R3. Let me do undebug and scroll up. Before it was at 3, and that's because the R1 fast 00 interface adds the metrics of 1, but now as we just change that to 3, so it's increased it by 2, that's why it has become 5. And you can see it right here as well within the route update messages. But actually, if you really want to do what the task said, which is increase it by 3, we should have made it 6. So the metrics offset should have been 4. And we're just going to have to wait for the new updates to come in. And hopefully this value right here will turn to 6. And there you go, it just changed to 6. So that pretty much complete that particular task. Next we are going to move on or configure the router 2 to advertise a default route. And the way to do that is to get under the interface facing the network that you want to advertise a default route and do the IPv6 RIP LM, and the question mark here we have an option for default route information or default information, question mark, and then you do originate. Okay, now give it a few seconds for the update to come in, and on R1 to show IPv6 route RIP. Here we have a default route, and hopefully that comes all the way to R3 as well, which it did. And now from R3 we should be able to ping pretty much all the loopbacks on R2. So if we do ping 2001.20.02, see that's pingable. That's loopback 1 on R2, Then here's loopback 2 on R2, and that's loopback 3 on R2. Okay, so pretty straightforward as far as having a router advertise a default route into RIP. It doesn't even have to own or have a default route exist in their own routing table, so it's considered unconditional advertisement here, where R2 doesn't need to check for a default route or existence of a default route in its routing table before it advertises a default route. Okay, so let's move on to the next task, which is task number 3 with route filter. We are going to configure R1 so that R3 will no longer receives R2 loopback 0. So refer back to the diagram right here. And R3 should still be able to reach R2 loopback 0. Okay, so just to plan for that, what we're going to do is to configure a route filter facing R3, so as the R1 advertised the routes to R3, it would not advertise R2 loopback 0. And before we start, let's check that on R3. We have R2 loopback 0, which is right here, 2001-2. So now on R1, the first thing we are going to configure is a prefix list, so IPv6 prefix list. I'm going to call it to R3 to indicate the direction, and then we'll do deny 2001-2 128. Okay, which is the exact match of right here, 2001-2 128 to match the R2 loopback 0 IP. And then we need to make sure that everything else will be permitted. So we need to insert a permit statement underneath that match any route. So : /0 less than or equal to 128. Okay, then we get under the RIP routing process, under the IPv6 router RIP LM. And then the command that we need is the distribute list. You can see all you can specify here is a prefix list. There's no route map or access list. So prefix list name, we use it to R3. And we want to make sure the direction is out. And the interface we want to configure that on is fasten00, which is facing R3. Okay, now if you do debug IPv6 RIP just to see what's going on, give it a couple seconds. There, I think it just sent out another updates. Let me do a UAll and then scroll up. You can see right here sending a multicast update to, let me see if I can find fast00. You can see just right before that said output filter suppressed 2001-2, which is the R2 loopback 0. And you can see right here as part of the update messages, this no longer contains the R2 loopback 0. Okay, if we now go over to R3, do up arrow, see still there, that's probably because it hasn't timed out quite yet. So what we have to do is to kind of force it a little bit with clear IPv6 route. And then just have to wait for R3 to get the next round of updates. Looks like it hasn't gone quite yet. We make sure we do show IPv6 prefix list detail and make sure there's a match. You can see right here there's a hit count of 4 for the deny statement. We clear it one more time. Let me make sure I configure that correctly. So let's take a quick look at under the router process, which is IPv6 route. Okay, so there you go. So you can see that 2001-2 has now gone. It just took a little while there, since the RIP is not the fastest protocol. So, but if you're trying to ping 2001-2, you can still see that's still pingable because the packet will follow the regular default route to reach R2 because R2 is currently advertising a default route. So that completes our task number 3. So let's move on to our next and final task, which is task number 4 with redistribution and summarization. So now on R3, we want to redistribute R3 loopback 1 and 2 into RIP with metrics of 1. And then we're going to configure a smallest route summarization for R3 to include all of its loopback 1 through 3. And then we're going to verify that R2 only receives the summarized routes and can reach all of the R3 loopback 1 through 3. Okay, so start off first with the redistribution part of it. So now here we're currently on R3. Config T. Let's configure an IPv6 prefix list that will includes the R3 loopback addresses. So we'll call the R3 loopback and then permit. Let's take a quick look at the R3 loopback subnet. So that's 2003.0.0.1 and 2. So that will be, to include all that is 2001.3.0.0, and then to include 3 subnets, we're going to have to do slash, or actually the task is asking us to only do loopback 1 and 2, so that's 2 subnet. So we need a slash 63 less than equal 64. Then we come up with a route map that will redistribute connected to RIP. So we'll call con to RIP, permit 10, match IPv6 address prefix list, and here's our matching prefix list. And now we need to get under IPv6 router RIP LM, and the command that we want is redistribute connected, since those loopbacks are considered connected interface. And then route map, we had it call con to RIP, and the task also said that we want the metrics to be set to 1. Okay, enter. Let's do show IPv6 prefix list details. Always a good idea to check if there is any match. Right here, you can see hit counts as 4 for those. So if we now go over to R2 and do show IPv6 route RIP, hopefully the update comes in already, and it has right here. It's got the 2 subnets that belongs to R3 loopback 1 and 2, just like how we specify using the matching prefix list. Okay, let's do a quick ping test. Oop, it's a wrong IP there. Try again. It ends with 3, so that's loopback 1. That's loopback 2. When we're trying to ping loopback number 3, you can see it doesn't have any routes to that just quite yet, and that leads us to the next task with the route summarization. So now on R3, let's do a debug IPv6 RIP before we configure the summarization. So the task says that we want to configure the smallest route summarization to include all of the R3 loopback 1 through 3. And since on the loopback 1, 2, and 3 in R3 there are 3 contiguous subnet from 0, 1, and 2, so our route summarization is going to look like IPv6 RIP LM. Command is summary address, and for the prefix it's 2001.3.0.0 and 0, but this time it'll be slash 62, because since we have 3 contiguous subnet and the smallest we can go is 62, which includes 4 subnets. Enter. And on R1, let's get ready and clear IPv6 route, and on R2 as well. And now let's wait for the next round of updates and see what we have here. And if you scroll up, you can see right here, sending multicast update out of fast 00. You can see instead of sending the 3 individuals, or actually 2 individual routes for loopback 1 and 2, it's now become a single summary route, so slash 62 right here. So now that we saw that, let's hop onto R2 and do show IPv6 route RIP, just to see if that 62 had came in already. You can see it has, but the the more specific routes of loopback 1 and 2 of R3 hasn't quite gone yet, but that's going to take the timeout. But for our testing purposes, let's go ahead and ping 3003, which is again loopback 1. Although it might still be following this route right here, that's supposed to go away. But before, if you're trying to ping R3 loopback 2, which was this guy right here, it wasn't pingable. If you're trying to ping, you can see it's now pingable because the packet is now following that summary route. You can see now those 2 specific routes are now gone, and we're just left with the single summary route. We could try to ping again. Right here, loopback 1 on R3, loopback 2 on R3, and then loopback 3 on R3. Okay, so it's pretty straightforward as far as configuration. Nothing really has changed too much from RIPv2 other than the fact that you need to enable RIP on the interface instead of using the network command. And comparing to RIPv2, RIPng potentially have less features for the current version of iOS. So this pretty much wraps up our video on IPv6 with RIPng. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.